LDRD is, of course, Laboratory Directed Research and Development. In this particular national lab, you have a lot of cross-cutting between people who do a lot of applied research and also people who have a very strong background in basic science. So we're combining those to create some very unique capabilities. This is a new field of microbiology, understanding how bacteria transfer electrons to solid objects. So we could use bacteria to generate electricity. We could also use electrochemical principles to understand bacteria, where we can use a lot of electrochemistry to understand how bacteria are working in the subsurface and monitor the microbial activity in real time. So this is really expanding far beyond what we ever imagined we would be able to do with it.
LDRD gives us an opportunity to explore new scientific principles and ideas, to think about fundamental science and how we can use fundamental science to enhance different research opportunities that we are exploring. We're trying to understand how adding defects and dopants and graphene edges to nanotubes can enhance their performance and properties for clean energy applications. It enables us to explore new materials that can significantly enhance the performance of these supercapacitors and batteries. So that helps increase DOE targets for energy applications.
This is the perfect venue for resolving these ideas and developing into something that is not only interesting, but also useful for solving DOE's problems. It's a mouthful. Functionalized magnetic mesoporous silica nanoparticles. This is a good use of an acronym, so we call it the MMSNs. And the purpose of these nanoparticles is to absorb contaminants. There's a big contaminated area. We could throw these nanoparticles into the area, let them mix with the uranium-contaminated water, and then we would retrieve the uranium bound to the nanoparticles with the magnet, and we can pull it back out.
Pop cells because of...
So it's a great return of investment, and I think it's very critical for the lab to be able to develop new areas for research. And this is a program that let you think out of the box, and this is very fulfilling for a researcher. Currently, we had 2 LDRDs for high temperature molten salt. One of them is using MAX materials, which are materials that give a combination of metal and ceramics and give a specific properties. And we use that, for example, for corrosion prevention, not only in molten salt systems, but we also use it for concentrated solar power.
The LDRD program allows me some kind of flexibility between continuing the professional development and seeking new areas of research. Hydrogen fuel cells are being looked as the next generation of energy conversion. More than half of the cost comes from the catalyst. Currently, they use a lot of platinum, which is a precious metal. So we're taking carbon materials and we add some of these chelating agents in the system in order to form those active groups. And that way, through using different activation procedures, we're able to take that material and completely eliminate the use of precious metal catalysts, therefore lowering the cost of fuel cells.
I've been at this work in material science and separations for about 30 years now, and it's rare to have a morning that I am not excited about coming into work. So the LDRD project we're working on is looking at the structure graphene. And graphene is a sheet material, impermeable to gases, but in particular what we're interested in is what happens when we start engineering defects into the graphene lattice itself. As we punch holes or make lattice defects in the structure, how does that affect the movement of gases and the development of a gas permeable membrane for applications such as gas separation?
The LDRD program is very special. It gives us an opportunity to develop new capabilities and explore new areas.
We have a clever idea, and this might be the first time anyone had this clever idea that works out in such a way. It's sort of an adrenaline rush.
It positions SRNL to be competitive in the research community.
It allows the younger researchers to cut their teeth on the proposal process and develop ideas of their own.
We kind of pave that path towards outside funding and outside projects that are really intriguing.
The LDRD program is the innovative engine for the Savannah River National Laboratory.